Hello, and welcome to the XAP 10 Global HTTP Session Sharing Screencast. My name is Shay Hassidim, Deputy CTO at GigaSpaces. Our agenda for today includes the following. We'll review the most common web application challenges. We'll introduce XAP Global HTTP sharing technology. We'll review the different session sharing models supported, the single application session sharing, and the multi-application session sharing. We'll describe how XAP Global HTTP session sharing allows you to share the same HTTP session across different JEE containers, as well as across different data centers. We'll then describe the configuration requirements to enable the XAP Global HTTP session sharing with your web application. And lastly, we'll present a demo illustrating both single application and multi-application session sharing. Web application challenges. Storing user sessions on disk or within the database slows down the application. This is a well-known problem. Current session availability implementations using these technologies do not scale well with increasing user traffic. When deploying large web applications, EAR or WAR files, it takes time to test each change. Many times, the desired solution is to break the large EAR or WAR file into multiple EAR or WAR files to simplify the testing process. These different deployed modules comprise the entire logical application, but these usually run in different web servers hosted on different machines. In this case, sharing the session across these different application modules becomes a major challenge. Many times, the session data wasn't meant to be distributed across different JEE containers. The most difficult issue to handle is serialization. You may not even have the ability to modify the original source code to make every session serializable, as you might not have the original source code. The session might use third-party library objects where you might not have the source code. Modifying code for large-scale applications to support session sharing may involve updating sensitive code. In many cases, altering such sensitive code is not an option. Sharing user session across multiple data centers is another very challenging issue. Any large organization has active-active or active-passive multi-site deployment architecture, where the HTTP session should be available across different web servers, sometimes from different vendors. HTTP session might be changing very frequently. The problem is that most DR and cross-site data sharing implementations rely on slow database replication mechanisms that do not handle rapid session updates very well over the wide area network. Lastly, high web server memory footprint is a major concern. Storing all existing users' HTTP sessions in process, with each web server process increasing the web server memory footprint, is a potential source for garbage collection, and eventually long pauses. Most organizations cannot tolerate such pauses or delays in their website responsiveness. Meet XAP Global HTTP Session Sharing. XAP Global HTTP Session Sharing stores HTTP session data within an in-memory data grid. No hard disk or database access anywhere. It may store the entire session on heap or off heap within local or central flash device, providing performance and scalability. It is sharing the session across different web applications transparently. No code changes required. It's sharing the HTTP session across different JEE containers. For example, you can share the session across different versions of Tomcat, or share the sessions between Tomcat and JBoss, WebLogic, or WebSphere. You may have the primary data center running a WebSphere cluster, and a disaster recovery site running a Tomcat cluster to reduce the overall cost. Lastly, you can share HTTP sessions across different data centers, clouds, or between the static portion of the website and its extension that scales in an elastic manner on the cloud. Let's look at the additional features included. Transparent web application failover. This allows the web application to be restarted without any session data loss. Support for any session data type attribute. Support for primitive and non-primitive data types, as well as for serialized and non-serialized session attributes. Session attributes do not need to implement the serializable interface. Sticky and non-sticky session supported as well. Your request can move across multiple instances of the web application seamlessly. Atomic HTTP request session access support. Multiple requests for the session attributes within the same HTTP request will be served without performing any external remote calls. The session state will be stored within the in-memory data grid when the HTTP request is fully completed. Total session visibility. Session content can be viewed and monitored in real time using the Advanced Admin Console. Role-based SSO support. Session compression encryption when transmitted over the network, providing maximum performance and security. And very simple setup. Single application session sharing. With this session sharing model, the web user interacts with multiple web servers through a load balancer, where each web server runs the same web application. We're running, in this case, multiple instances of the same web apps in a cluster configuration. The load balancer routes requests based on the sticky session configuration to the relevant web server instance. In this scenario, the session is shared via its ID. Where there is a web server failure, or when a new web server is added to the cluster, the session ID is used to retrieve the session from the in-memory data grid. Only the delta is sent to the in-memory data grid when the session is updated. This ensures maximum performance and optimal bandwidth usage. Multi-application session sharing. With this session sharing model, the web user interacts with multiple web servers through a load balancer, with each server running a different web application. It may be one logical big web application that has been broken down into different modules such as web portals, each running a different web server, potentially running on a different host. Each web app may access different web apps during the life cycle of the application. In this scenario, the session user login, the principal, is used to identify the session to be shared across the different applications. You may also have multiple instances of each web application running to scale its activity. All will be sharing the same HTTP session transparently. Any new web server that will be added dynamically will be able to share the session. When a session is updated, only the delta is sent to the in-memory data grid. When the session is shared between different web applications, where each might have a different version of the session, a timestamp check is performed to ensure that there is no session attribute data loss before the session is stored within the data grid. In this case, session attributes are merged to ensure session data consistency when navigating between the different web apps modules. Session replication across different JEE containers. The XAP Session Manager is universal. It supports session sharing between different JEE containers transparently. There's no lock-in into a specific JEE container. You may have a web deployment production environment in which different JEE containers from different vendors are used to host the web application, all sharing the same HTTP session. This may be very useful when upgrading your web environment. For example, from Tomcat 6 to Tomcat 7, or from WebSphere 7 to WebSphere 8. In this case, no downtime would be required. You may start a new web container and terminate old ones. The new one will fetch the latest user session from the in-memory data grid to resume user activity without any interruptions. Sharing HTTP sessions between different JEE containers will be useful as well when deploying the web application across multiple data centers. But use, for example, commercial WebSphere JEE containers at the active production data center, and Tomcat open source at the disaster recovery secondary site. This may reduce overall costs. In this case, both can share the same session transparently. Session replication across different data centers. The XAP in-memory data grid supports data replication over the WAN or LAN. You may use these functionalities to replicate the HTTP session to remote sites. There's no special configuration required from the application side to enable this. This allows you to replicate the session to remote data centers running the same or different web application. For example, a cloud environment to better scale your web applications or to support DR. You may use active-active or active-passive replication architecture. When the session's updated, only the delta is transferred over the network to remote sites. You may compress and encrypt the transmission. HTTP session management, a closer look. XAP session sharing, using a standard JEE filter that you add to your application configuration. This filter acts as the access point to the XAP HTTP session manager. It uses Shiro open source under the hood. This filter interacts with the in-memory data grid when the session data needs to be retrieved or when the master copy needs to be updated. Such interactions with the in-memory data grid occur only when the HTTP request has been fully completed. This ensures total data consistency when persisting the session's changes. It's very important with advanced web applications that use AJAX, WebSocket, or other multi-threaded webs frameworks. The changes to the web application configuration that are required to enable XAP session sharing are very minimal. Add the GigaSpaces HTTP session filter as illustrated. Very simple. Demo. Our demo will illustrate single application session sharing and multiple application session sharing. The demo is available on the global HTTP session sharing documentation page. XAP HTTP Session Sharing Demo 1. This demo simulates adding a new web server to scale a web application or a node failure, where requests are routed into another web application node with no user HTTP session data loss. With this demo, we'll deploy a single web app into Tomcat 7. Note that the same demo can use JBoss, WebSphere, or any other JEE container. We will update the session, terminate Tomcat, and restart it, and see how the HTTP session data is fully recovered. The demo can be downloaded from the global session sharing page, as seen here, by following the steps provided. Okay, let's get started. So we'll open the GigaSpaces bin folder. This folder is created once you unzip the GigaSpaces distribution. We'll apply the license file that you get once you download XAP. And start the GigaSpaces agent. We'll also start the GigaSpaces Web UI server. Once this tool has been fully started, we will access the GigaSpaces UI. We can do that through this URL. And log in. Now we'll deploy a data grid called Session Space. We can pick any cluster topology. For now, we use the partitioned sync2 backup. Basically one partition with a single primary instance and one backup instance, and deploy. It'll take a few seconds for the data grid to be deployed. So in the meantime, we'll take a look at the web application configuration. The web app configuration includes the GigaSpaces HTTP sessions filter. As you can see over here. This is actually the only configuration that needs to be added into your existing web XML. The other configuration is actually a configuration file called Shiro ini file, which includes several properties. But the most important one is the connector URL. As you can see, here's the name of the data grid that we just deployed, and the lookup service host name. In this case, it's called localhost. I'd also like to mention that the data grid can be deployed as well through the CLI or API. Let's take a look at our deployed data grid. We can see it over here. Now we have no data within it. Let's start our Tomcat server. Tomcat is started. Let's access our web application. This is our web application. We can add attributes very easily. We can edit attributes. Note that each activity we are doing is stored within the data grid automatically and also being logged. So we can see that if, for example, we add another attribute, we'll see it over here within Tomcat. So let's terminate Tomcat. Okay, that's it. No Tomcat. The session content is replicated continuously to the data grid. We can see it over here within the XAP Web UI. That's the session object within the data grid and includes the session's data. Let's refresh the web page. Obviously, since there's no web server running, the page will fail. Let's now restart Tomcat. Now if we refresh the page, we'll see that the session is fully recovered from the data grid. And look, we have it back. We've got all of our session data back, and we can continue and add attributes as usual without any data loss. XAP HTTP Session Sharing, Demo 2. With this demo, we'll have multiple different web applications sharing the same HTTP session. We'll deploy one app into Tomcat 7. We'll then deploy another app, a different app, into JBoss 7. So with this demo, we will have two different JEE containers running. We'll update the session with the Tomcat app and see how it's shared with the JBoss app and vice versa. Later, to demonstrate failover and session recoverability, we will terminate Tomcat and JBoss altogether and restart them, and see how the session will be fully recovered with both JEE containers. Let's move to the demo. So we've got here a data grid with a single partition running primary and backup instances. As you can see, it's empty. There's no data within the grid. We'll now deploy our web applications. We've got our JBoss environment and our Tomcat environment. Let's start Tomcat. And let's start JBoss. The web applications that will be running will have a Shiro INI file. That file looks like this. We have the connector URL as usual, but also an authentication login URL, which specifies the login page that will be used to authenticate the user for each deployed application. In this case, the username or the principal is used to identify the session. This is how it's shared between applications. So let's access these apps. We'll use this URL for Tomcat and this URL for JBoss. The demo app includes several usernames and passwords that can be used. We'll use the root username and secret password for Tomcat. And we're in. And we'll use the root and secret credentials with JBoss as well. And we're in. Now with the Tomcat application, we'll add a few attributes. We've added A and B attributes here. If we refresh the browser accessing the JBoss application, we will see these attributes. Now we'll add C attribute and see that it appears within the application. Same for D. You can see that I'm switching between the JBoss and Tomcat applications, and all of the attributes are accounted for. You'll see that the session has a different ID for each application server, but the data is fully shared between the different apps that are actually running on different JEE containers. Now, I'll demonstrate a session failure and recovery. So we will terminate both JBoss and Tomcat. Now if we try to refresh the session, it will obviously fail. Now let's restart these two again. So we're restarting JBoss. And we'll restart Tomcat. We'll re-access the session. Refresh the page here. We'll use the same username and password. Here we go. We've got the session contents back in JBoss, and we'll do the same for Tomcat. Log in. We're in. We have the session back. We can continue and update the session with both of the different apps without any data loss. If we switch back to the GigaSpaces web UI, we'll see our session over here, and we can access the session as usual and see it over here. That's the actual content of the session. This concludes our demo. Thanks for watching.